focused on a lot of the CIMSS products and SSCC products that are adding to the toolbox of what the Hurricane Center is using to predict this thing. And we'll focus less on that in this briefing and more just on the actual forecast, because that's probably why people are here. You all have relatives or friends or somebody along the path there, and it's shifting every cycle. So we'll give you the latest on what we see here.
Okay, well, we'll go ahead and get started. So greetings, everyone, from the University of Wisconsin. This is the afternoon briefing on Hurricane Irma. I'm Derek Herndon. This is Sarah Griffin. We're going to talk about the current conditions with Irma, what the storm has been doing over the last 24 hours. And then obviously we're going to talk a little bit about the forecast and the potential impacts on the Bahamas, Cuba, and Florida, and then beyond that going forward. So this is the latest advisory from the National Hurricane Center at 2 p.m. Irma is now passing north of Hispaniola as a Category 5 hurricane still. Sustained winds are 175 miles per hour. That's down slightly from yesterday. There's been a little bit of weakening in the storm, primarily due to what we think is an eyewall replacement cycle that has occurred over the last 24 hours. Storm is still moving to the west-northwest at a pretty good clip, about 16 miles per hour. And we expect that to continue for the next few days, and then gradually slowing down north of Cuba. And then the timing of this turn to the north, obviously, is critical for its impacts on Florida. And Sarah will talk a little bit about the forecast in a bit. Still have hurricane warnings up for the northern coast of Haiti and the Dominican Republic, for almost all of the Bahamas. I believe that's all of Bahamas. Hurricane watch is now up for Florida, and those hurricane watches will likely be extended north, possibly at the 5 p.m. advisory, but certainly by the 11 p.m. we should see an extension of those watches up to the north along the coast of Florida, both the west coast and possibly in the east coast. Okay, next image. We do have two other storms out there. We have Hurricane Hosea, which is out to the east-southeast of Irma, and then we have Hurricane Katia in the Gulf of Mexico. Katia and Hosea have both been intensifying. Hosea is approaching major hurricane status. The presence of the eye in the image here and also some objective estimates from the advanced Dvorak technique suggest that this storm could reach Category 3 probably later today, maybe tonight. Katia also intensifying, but the Hurricane Center has that system going to about 90 knots. Interestingly, I asked some folks this morning, has there ever been a case when there were 3 Category 3 or higher hurricanes in the Atlantic, so 3 major hurricanes at the same time? And the answer is no, that has never happened to our knowledge. So that would be interesting if Katia were able to intensify further. Otherwise, on this image, we can see a cold front that's come off the east coast with the front draping down into North Florida. An unusually strong upper trough is moving through the center part of the United States, the Great Lakes, and then to the east coast. This feature is critical for the future path of Irma as it weakens the subtropical ridge north of the storm, and weakens it such that that's when Irma will move through that break and make that turn to the north. Again, the timing of that is pretty critical, but we think that the models are starting to come into focus now, where we're only 72 hours out. Okay, next image. So taking a look at the GHOST 16 animation infrared for the last several hours. Irma is a classic Cape Verde major hurricane. Very symmetric. Convection is very symmetric around the eye. Earlier this morning, we saw some breaks in the western eyewall and some of the satellite imagery. We believe that there's another eyewall replacement cycle that's ongoing at this time, and that might have been responsible for the breaks that we saw. The aircraft flying through the storm did find a double wind maximum, which confirms the presence of a double eyewall structure. And also, there's been a little bit of a weakening of the storm in the pressures and also the winds that the aircraft measured. So that is in line with what we would expect during an eyewall replacement cycle. As the inner eye begins to weaken, the storm tends to weaken a little bit. But then as the outer eye contracts, we could see intensification. Again, the waters ahead are very warm, and the environment is very favorable for the system to maintain Category 5 to Category 4 intensity for the next few days. Otherwise, we can see out ahead of the storm is fairly clear. This is fairly common in a major hurricane this time of year. Large-scale subsidence occurring out ahead of the storm. It's actually a beautiful day in South Florida. And that's really good in terms of evacuations. The weather's not impacting any of the evacuations in Florida at the moment, so that's good news. Okay, next. This is just a high-resolution, temporal resolution, 30-second imagery from GHOST 16 looking at the visible spectrum here. So we can see the eye very clearly here, convection wrapping around the system. We even see some presence of possibly some gravity waves emanating from the inner core convection here. Otherwise, the banding structure is very well organized, and you can see the cirrus spreading outward above. Again, the system is very well organized in terms of its symmetry and the upper level environment around the storm. Looks quite good. So in terms of the environment, we'll kind of dial into that a little bit more. So here is the IR presentation. One of the interesting things that we've seen today is that there's a little bit of a jog to the north of the forecasted track. I think this is probably just a type of a torquoidal wobble in the track of the storm, where the eye is kind of rotating around. And then also when we get these eyewall replacement cycles, that can impinge upon the inner eye and cause it to wobble a little bit. We expect this to wobble back to the west a little bit in the next few hours probably. And otherwise following along this forecasted track pretty closely. We're pretty confident in this part of the track here through the Turks Caicos and then just south of the Bahamas. Let's go ahead and look at the upper level winds. So what we'll do is we'll throw the upper level winds on this from the satellite imagery to take a look at the outflow structure. So we can see that the winds are emanating from the top of the hurricane. The outflow is extremely well developed, has been for most of this storm's existence. Pretty much a perfect upper level environment for a hurricane, and no indication that the area out ahead of the storm, at least up to Florida, would inhibit this storm from maintaining its Category 5, Category 4 status. Let's take a look at the ocean environment next. So now we're going to take a look at the sea surface temperatures. Interestingly, the storm has yet to actually move over the warmest water that's ahead of it. So the storm is currently located here, but out ahead along the track, the water gets even warmer. So it warms from about 29 to 30 Celsius up to 30 to 31 Celsius. And so the highest SSTs along the track are still ahead. So because of that in the upper level environment, it's hard to see anything that would weaken the storm other than perhaps some interaction from the higher terrain of Hispaniola and Cuba. Eastern Cuba, the mountains are pretty high here. Also the mountains in Haiti are pretty high, but at the moment it looks like the track of the storm would stay north of the island. So island interaction weakening the storm doesn't seem very likely at this time. We'll take a different look at this with the ocean heat content. So this looks at not only the temperature of the water, but how deep the water is in terms of the warmth and basically the potential energy available for the storm. And we can see that there's a warm pull out ahead to the Straits of Florida, the Gulf Stream current coming through here. The water is very warm and it's deep and warm. So even as the system moves across this water, it's unlikely to churn up colder water from below because the depth of the warm water is very deep there. So again, the ocean heat content and the upper level environment, very favorable. And we're a little concerned about the storm getting into this area in terms of its ability to draw the energy from the ocean there. It's probably going to depend on what the structure of the storm is at that time, where it is in these eyewall replacement cycles, whether or not it can make use of that ocean environment. The potential intensities on here, these numbers seem different than what they were earlier.
Yes, because this is ocean heat content.
So yeah, so I go to the potential intensities based on that ocean heat content and the upper level environment, showing that the potential intensity is 200 knots for this storm. So it's really actually overachieved its intensity over this region. The potential intensity throughout the region through here was 140 knots, and it got up to 160. So again, the environment ahead is favorable for the storm to maintain intensity. Some models do intensify the storm over the Florida Straits as it's coming into this region.
What was the lowest intensity we saw in some of those models? It's like 890 millibars or something?
Below 900 millibars.
Yeah.
Several of the models dropped the system's pressure below 900 millibars. It's certainly plausible.
Yeah.
It certainly could happen. The other thing, too, about this storm is that it's been growing in size. So as each eyewall replacement cycle has occurred, the eye has gotten a little bit larger. That's expanded the storm outward a bit. Also, it's wrapping in deep tropical moisture from its south and southeast, and that's also to act to expand the rain bands outward. So again, we have a strong storm, but also a storm that's growing horizontally in size.
What's the size of it right now, the eye?
I think the eye is on the order of about 25 nautical miles in diameter currently in the infrared, but the microwave suggests that that outer eye is much larger than that, and that I would expect that inner eye to weaken today, and then our outer eye to take over the next several hours and have a larger diameter at that point.
How far is it from coast to coast in Florida?
It's 90 miles across or so, 90 to 100 miles across, depending on where you're at on the peninsula. Yeah. Okay, let's go to the next image. So I mentioned these eyewall replacement cycles. So this is the MIMIC product, which uses the microwave imagery to look at the core of the tropical cyclone. So we can see it passing over the islands, unfortunately here north of Puerto Rico, now north of Hispaniola. So we see it had a primary, thick, well-developed inner eye wall structure, but then we can see these outer bands begin to wrap around that eye and form a secondary eye wall around the system. Just as it was passing north of Puerto Rico, you can see that secondary eye wall structure. The inner eye begins to weaken, the outer eye kind of takes over, and now we actually have another outer eye that's developed around the system. So I've counted 6 eyewall replacement cycles in this storm so far. Some of them are a little difficult to determine, but this one is quite clear. And the one that's occurring now is actually at a much larger radius than the previous ones were. So again, I think the storm will expand outward in its size because of this process. I also expect because of this particular eyewall replacement cycle, we will see some weakening with the storm, but probably only temporarily. It's still, the environment's very favorable, so it probably will recover from that pretty quickly. In addition to that, we have the radar data yesterday from Puerto Rico just showing the lower structure of the storm. Again, showing it passing over the islands. Again, we can see that double eyewall structure develop as it passes north of Puerto Rico there. Very obvious concentric eyewalls at that point. When we see the inner eyewall kind of get some breaks in it and kind of weakens a little bit, and then the outer eyewall takes over as the system moves away from the island there. Fortunately, the system moved fairly quickly, so rainfall, while bad in Puerto Rico, was not as bad as it could have been. Okay, next, please. Again, taking another look at the upper level wind structure and the outflow. This is a higher resolution using the GO-16. We can see the outflow winds are all very well defined here, very symmetric, with the flow moving away from the top of the hurricane here. One thing that will be interesting to see is that some of these winds begin to kind of connect with that trough off the east coast, if that aids the outflow in any way. Not that the system needs any help, but there does appear to be, in some of the models, some connection with this outflow to that trough as it's coming off the east coast of the United States. So now we'll take a quick look at some of the aircraft data. We can just go to the next tab there, I think will be fine. Just click on that. So aircraft fixes have been fairly consistent on this west-northwest track. The pressure has been fairly steady. We'll see these small fluctuations because the drop zones don't always fall directly in the center. So some of these drop zones will fall and have a little bit of wind with them, and we'll have to adjust those pressures downward a bit. But that 921, 922, 920, 923, 922, all pretty consistent with each other. I have noticed that the winds coming from the observations have been down just a little bit, especially the SFMR winds at the surface and the flight level winds. So it'll be interesting to see if the Hurricane Center wants to nudge the intensity down slightly, perhaps at 5 p.m. But there'll be a new aircraft in the system here shortly. Basically, we have a full court press of both NOAA aircraft, the Air Force C-130 Hurricane Hunters, and also the Gulfstream aircraft flying the environment around the storm.
So it's interesting, you don't really see that tricoidal oscillation much in the aircraft fixes there.
Does not show up much in the aircraft fixes, but it definitely shows up in the satellite imagery.
I wonder if the time in there is just too short or something to really see that.
Could be.
Derek, what's the longest Category 5 strength? Because it's maintained it now for how long?
I believe that this storm is a
Number
record
one.
storm. Yeah, in terms of maintaining Category 5 intensity for the length of time it's maintained, it's a record. So it already had broken the record for being the strongest storm in the Atlantic Basin outside of the Caribbean and the Gulf of Mexico, and now it's also the longest living Category 5, as far as I know.
National Weather Service is launching storms every 6 hours in the eastern side of the U.S.
So, so for our audience out there, one of the things we're trying to do is we're trying to gather as many observations outside of the storm as we can. So NOAA has asked all the upper air stations to launch upper air obs every 6 hours. We have 3 aircraft flying in the storm, and of course all the satellite assets that are being brought to bear to try and figure out where the storm is going to go. Okay, and then what do we have next?
Oh, just a plot for one of the winds, and you can see.
Oh yeah, so this was, we wanted to show just this is one of the aircraft transects through the system, and we can see as the aircraft flew through, we have a primary peak in the primary eyewall, and then the secondary peak just outside of the eyewall, basically confirming the double wind structure and the concentric eyewall structure, and verifying that an eyewall replacement cycle is indeed underway right now. So with that, I will hand it over to Sarah, who will talk about the forecast.
All right, so before we talk about the forecast, we're actually going to talk about past forecasts. So this is from Brian Tang, who is a professor at the University of Albany in upstate New York. And this is modeled trends. So what we have plotted here is these X's are the location of Irma from the National Hurricane Center every 6 hours. And these are forecasts going back the last day and a half, so the last 6 forecasts. The lighter it is, the older the forecast, the darker ones are the more recent forecasts. So this is the official forecast from the Hurricane Center, and we can see that these X's are pretty much right along the line of the forecast track, meaning that there is no bias right now in the National Hurricane Center track based on the center of Hurricane Irma.
That's just the official.
This is the official.
Yeah, after they've distilled all the model data.
So they actually captured that more west-northwest turn a little bit there nicely, and then have it turning back to the west, just very subtle there.
Yeah.
If you go look at the ECMWF, the European model, since we're only looking at the last day and a half, we only have 3 model times. But again, we can see that based on the National Hurricane Center track, the ECMWF has been very consistent with the center of Hurricane Irma. We will compare that though to the GFS. And right now the GFS has a slight north bias. You can see all these X's are pretty much right on the southern envelope of the GFS forecast track. The GFS has been trending south, but that could also be because that's where the center of Irma is actually to the south. So for the most part, the GFS ensembles have been to the north of where the center of Irma actually is.
And that could look pretty subtle, but boy, when you start talking about that right-hand turn in 72 hours, that could mean the difference.
Yeah.
It really could.
So that ECMWF there, that doesn't have the latest run that just
No.
came out.
It does not.
This also does not have the latest GFS run. We're only going out, we only have the 6Z run today. We do not have the 12Z run from today yet. Looking at some of the biases. Sorry, that's the wrong plot. So this is the mean bias error in the model intensity. So pretty much the difference between the model intensity and the actual intensity at different forecast hours, anywhere from 12 to 120 hours, so half a day to 5 days. The ECMWF is in brown, the official is here in pink. And you can see for the most part, all of the biases have been negative, meaning that the forecasts have been too low compared to the observed intensity of Irma. The ECMWF here looks like it's the worst. I'm not sure if this is related to the actual model intensity or because the ECMWF is a model that you do have to pay for, you can get lower resolution data for free.
Interesting.
So it could be that it's just lower resolution data and it's not capturing as strong of a hurricane as Irma actually is, where if you paid for it, you could actually get a better
I
model.
wonder if Brian gets the full res.
Yeah, I'm not sure what Brian actually gets.
I'll have to share this with him and ask him because it is important. I mean, based on that, the ECMWF is horrible.
Yeah.
That's nice close.
It's great on track and it sucks on the
But to be
intensity.
50 knots off
That's a lot.
That's a
after
lot.
after 12
Yeah.
hours, that
Yeah.
really argues for bad resolution.
Probably. Some models that are some models that are currently better than the official forecast include Ecmwf here in orange. This is a high resolution centered on Irma forecast.
Of course, a lot of those models, again, are initialized with a vortex that has the current intensity information. EC is not one of those.
Yeah.
So,
So if you look at mean position error, this is just in absolute error, so it doesn't tell you if it's north, south, east, or west. It just tells you the distance from the forecast center of Irma to the actual center of Irma. And here we can see the ECMWF is actually better than the official forecast in 120 hours. Fewer forecasts, there's only 7 because it's only run every 12 hours, I'm guessing, compared to the official, which is every 6 hours.
this is track again, right?
This is track,
Yeah,
yes.
right.
So it's mean absolute error in the track.
Yeah.
But consistently, the ECMWF is slightly better than the official
What's
forecast.
the dark blue there? Is that the CIMSS?
Dark
TC.
blue is, yeah.
Yeah, okay. That's the Navy coupled model.
Yep, and here we have the GFS right now is in brown, and you can see the GFS model errors being worse than the official errors in the pink. And again, as we saw, the track does seem to have a northward bias compared to the official forecast. So now let's start talking about the GFS. So this is the 12Z forecast that was run this morning. I have it started at 12Z. So this is the analysis hour. And we can also compare that to the ECMWF. This is also just came in. This is valid at 12Z this morning. You can see both of them are pretty much in the same location, which you would expect. This is a 12-hour forecast. Or excuse me, this is an analysis.
Pressure's way off, isn't it?
Pressure is way off, but again, I'm not sure if that's related to the resolution of the ECMWF because I'm pretty sure.
Aren't they both? Is it the GFS at 9?
Yeah, but the ECMWF initialization has routinely been very,
Right.
very weak.
Yeah.
It always catches up in the forecast. And
Sure.
it
Yeah.
spins the vortex up correctly and deepens it correctly, but the initialization's been very weak.
Yeah. So is that related to initialization, or is that related to the fact that you're just getting a lower resolution product because it's free?
And does the GFS analysis have the focus in it?
Mhm.
It does.
Yes.
So a lot of that is what they've added, right?
All right, so we'll jump ahead. The GFS go out one day. So here we are tomorrow morning. The GFS is well north of Cuba. I know some previous forecasts had Irma going into Cuba, and while that would be bad for Cubans, that could be better for Florida, just because if Irma had gone into Cuba, there's very high terrain in Cuba, so it would have acted kind of tear at the center of Irma and weaken it a little bit. Go ahead and compare that to the ECMWF, which we only get in 24-hour increments. They're pretty much the same spot. The ECMWF is a bit to the south and to the west, but again, this could be the GFS bias in that the model tracks have been more to the north compared to the official. Back to
Pretty
the-
much the same with Hosea too.
Back again, another 48 hours. Jump ahead in the ECMWF.
So this is Saturday morning now,
Yes,
right?
we are now at around 7 a.m. Central Time Saturday morning. And again, we're seeing kind of the same thing. The GFS is farther to the north and then farther to the east. ECMWF is just a little bit more to the south and the
Shows it
west.
impacting Cuba more.
Right.
Yeah. So now once we get to 72 hours, this is when the forecast changes, not to give it away. Here's the GFS at 72 hours. It's 9:03, spinning right off the coast of Miami. Go to the ECMWF.
Big difference.
And this is now 9:27, which again could be related to the resolution issues, but it's farther to the west. It's now directly over the Keys.
Funny, if this were over the middle of the ocean, we go, look how close they are.
Yeah.
But now we're going, oh my God, totally different.
Well, just the damage pattern.
Yeah, the impact
And what's
is,
the pressure there?
927. Again, I don't know if it's a lower pressure, we just don't have that resolution.
Well, if that's the course resolution model and it's 927, then that's concerning.
yeah.
But it's not a course resolution model, they're just degrading.
Right.
Yeah, they grade the product that they
Right.
send out. So let's go back a little bit. So this is, let me just make sure these are valid. Yep, these are valid at the same time. So this is from the 0Z model, or excuse me, the 12Z model that was run yesterday. And you can see there is this shift in the ECMWF to the west from the previous, the forecast run a day ago. If we go back another day, here it was way over Cuba. So we are seeing a little bit of a subtle shift west though, but there was a big jump to yesterday and just a minute jump from yesterday's forecast to today's forecast, but it's still just a
That
little
will
bit.
impact both coasts.
Yeah.
It's right up the middle.
Let's do the same thing in the GFS. And the GFS for the most part has been very consistent. It seems to keep wanting to be right off the coast of Miami.
Yeah.
I mean, I've gone back now quite a few forecast runs and it's still in the same spot. The pressure's changing a little bit, but the location hasn't really moved. And so the interesting thing will be, is the GFS just locked into this is the track it's going to be, and now that the ECMWF starting to shift west, I really don't want to be a forecaster in this right now just because,
Come on.
yeah, if this was out in the middle of nowhere, I'd be like, this is so close. This is where the hurricane's going to be. But the fact that we are, we're talking Florida, which is, as Derek said, 90 to 100 miles across, depending upon where it is.
And if the EC shifts just a little bit farther to the west, then the entire Gulf Coast of Florida gets.
True, but the Everglades area there is not very populated.
No, it's all
The
marshy.
Keys, this would be very bad for the Keys, but it's better for the Miami-Dade County area because you take the core of the winds more to the south and west. They would still experience hurricane force winds and surge and everything that goes with that, but they don't experience the core of the hurricane.
And the Keys have evacuated already.
Keys
are
are-
under mandatory evacuation. I don't think Miami, they started doing evacuations, I believe, in zone A and B starting today.
Right.
People
But-
were leaving voluntarily, but the Keys have mandatorily been evacuated.
I was just saying if this then goes north.
Right,
Well,
so
let's see.
let's go forward and see.
Yes,
Whoa,
and it just goes right off the spine.
Yeah. Disney World.
But if it goes up north off the coast and then comes in,
Yeah.
in that 24 hours in between there, which is kind of crucial.
Yeah, and so the GFS has it pretty much just riding the coast. It does
Because
go
I
to
know a lot of people that have evacuated already from Miami to Fort Myers.
And Orlando. area.
Well,
Oh.
I'm a
See,
little
my husband's
curious-
coworker,
People
they
are
just
doing
told him to go to Tampa.
I'm a little
So
curious why people would make that choice because Fort Myers and Tampa have always been incumbent.
Yeah.
So,
I think they did
people are-
that because, well, the people I know did that because they knew people in Fort Myers.
Right.
So they went to.
well, as
lot
long
of
as
it
they're
was
inland and
just-
have a strong structure, that you're okay. It's
well, a lot of it was also what was available. Where could you stay as well?
right.
And
That's
a lot
also
of
an
people
issue.
made the decision to go to Tampa a couple days ago when we didn't have this westward shift in
Right.
the EC.
It's still less likely to get surge in Tampa unless it really swings.
Yeah.
Right.
But do you
for
want
the
to be in a
Tampa-
high-rise hotel as it's coming up the spine? Is the
Yeah.
question.
The Tampa forecast is problematic if we get another westward shift and it goes up the west coast because you take that surge right into Tampa Bay.
Right.
Yeah.
And that's the nightmare scenario for Tampa, is that a storm, a strong Category 4, Category 5 hurricane coming from the southern Gulf, moving due north, pushes the surge directly into
Yeah.
Tampa Bay. And that
Tampa
has,
Bay is right around
Tampa has
there.
not experienced a major hurricane since 1950. Hurricane Easy in 1950.
Easy.
That's how long. Yep.
Easy?
Yep.
So
That's
Like a
how
Sunday
long
morning?
it's been since Tampa has had a major hurricane.
these are the 850 winds, the magnitudes, right?
Yes.
Is there a good inland rule of forecasting 850 winds equals approximate gust strength or anything like that?
Yeah, the ships has a decay model that allows for overland decay of the storm and the winds. So we could look at the decay ships to see what it's showing, the maximum winds and how those decay.
It's all track on this.
But one thing we were just discussing is that South Florida, south of,
And here's
south
the
of
10 meter per second, or
Yeah.
10 meter winds.
I don't think we have that for the
I don't know.
ECMWF, but you can kind of see the decay there,
Sure.
based on the how the winds decay over land, based on the model anyway. But one thing about this track over South Florida, this is the GFS, the ECMWF is over South Florida. Everything south of Lake Okeechobee is almost water, and it's
Yeah.
warm water. We've actually seen hurricanes and tropical storms intensify over South Florida. So, this overland portion south of Lake Okeechobee, probably not too much of a factor because that's very wet and very warm there. The hurricane probably would not lose much intensity there. It wouldn't be until it got north of Lake Okeechobee that we would start to see the decay and the winds really kind of kick in. But again, a large part of this circulation, and it is a large circulation, is still over warm water. So the decay of this storm over land is going to be slower than, say, Hurricane Charlie or a much smaller storm that's moving over land.
But these two tracks, if you do GFS, then you've got the surge in the Georgia coastline.
Yeah.
Whereas
If we
in
can,
Right.
yeah, we can.
So the biggest difference I see in this forecast is where does the surge happen? Do we get a southeast U.S., a southeast Florida surge and surge all the way up the east coast of Florida into Georgia and South Carolina? Or do we get a track that's further west and actually diminishes the surge over much of the southeast United States? And the only thing that would be a problem for Tampa is if the storm moved offshore. Now, there is some indication of a turn more to the west, but it's hard to see it moving over enough water for that to be too much of an issue.
Do you think they'll begin considering evacuation in Tampa?
No,
Uh,
I don't think so.
I think that they'll probably recommend people in Tampa Bay, right on the water area, will probably need to evacuate as a precaution, basically trying to account for model forecast uncertainty. Because the storm could shift enough that Tampa Bay would get enough of an onshore component to the flow to push the surge into Tampa Bay. So at the moment, that doesn't appear likely, but it's certainly possible based on the ensemble forecasts.
They're evacuating coastal Georgia today, mandatory.
Yep. Well, if you follow the GFS track, it makes landfall right on the Georgia-South Carolina border.
It's all
Is that
shallow,
Savannah right there? Where it
That's
hits?
Savannah.
Yes.
Savannah.
Wow.
and they're very susceptible to surging.
Yikes.
Yeah.
And the whole Georgia coastline.
Yeah. Now, if we go back just 12 hours ago on the ECMWF, it was something fairly similar. It hugged the coast a little bit more, but it made landfall around central Georgia.
How much of a difference for inland winds is it coming on as, say, a strong 4 versus a beefy 5? The initial intensity at landfall. I mean, given that energy is with proportion of the wind speed,
Right.
is it that big of a difference?
I think it would be. I think that the stronger the storm is coming on land, it's just going to take that much longer to decay.
Right.
So you're going to get, hurricane force, 100-mile-an-hour plus gusts all the way up the peninsula, possibly even in Tampa, based on these forecasts. So, again, the extreme part of the Everglades aren't very populated, but everything north of Lake Okeechobee is, and certainly the Fort Myers area, the Tampa area, Orlando, again. Remember in Hurricane Charlie, when Hurricane Charlie made landfall in southwest Florida as a Category 4 it did a tremendous amount of damage in the Orlando area, even though it had moved over a fair amount of land at that point. So and that was a much smaller core storm.
The other thing is you notice the speed picks up a little bit as it's coming up the coast of Florida. So you have to add that component onto the right side as well, which would be another 20 knots.
I suppose it gives it less time to spin down as well.
Also, we think that at this point, wind shear is going to start to impact the storm from the trough that's to the north and another piece of energy that's dropping into the Gulf of Mexico. So that will probably redistribute the precipitation pattern a little bit around the storm. So typically with that pattern, we see that the western side of the storm is a bit drier. I mean, there's still going to be a lot of rainfall and heavy rainfall wrapping around. But the amount of winds that get down to the surface also have a component that's related to the convection. And so
GFS.
You're gonna do that in GFS. I was gonna go to the H-Wharf model.
Can't you do that one?
yeah, well, we could do H-Wharf, which will have a better representation.
So I was gonna do H-Wharf and then head of the radar. This is the 12Z H-Wharf, which had been more accurate than the official forecast in terms of, I believe it was intensity.
So for those who are watching remotely, this is Florida here. It's hard to see a little bit, but Florida's right there.
Oh, it's storm center.
Yeah, so if we get it back to, it's storm centered. So here we are around midnight on Friday night. Here's Cuba, just north of Cuba. And this is simulated radar.
It's neat. You can even see double eyewalls in some of the scenery.
It drops 10 millibars.
Yeah.
It drops 10
What is it,
millibars.
9?
17.
So
Yeah.
H-Wharf is able to do eyewall replacements?
So yeah,
Well-
we definitely have seen that. We've definitely seen the high resolution.
Timing is everything.
Yeah, the high resolution models do have the ability to simulate eyewall replacements, but the timing is almost never correct. They can simply tell you that the environment is favorable for it, and we know that it is. It's just a matter of timing as to what will be the structure of the inner core when it approaches South Florida, and that's really impossible to know at this point.
Do they have a sense of the physics behind it?
I mean, it's a cloud resolving,
I mean,
model, so I think it just lets it.
Not the numerics, but the.
Right.
So that's
In terms of the
934 on the
banding
coast of
structure, the actual eyewall
944
formation.
on the coast of Georgia.
Yeah, I think we're getting a better handle on that, especially with some of the aircraft data that we're gathering in the inner core.
That dry air, is that what's causing that?
Yeah, so I think there's some dry air entrainment. This is how far out? So that's over.
Looks like
Yeah.
Looks like a pattern.
Well, shear too might be hitting it.
Some shear.
So even at 944 striking Georgia, I mean, that's still pretty significant.
Yeah, it had it actually coming, H-Wharf actually had it coming ashore around the Miami area
Mar-a-Lago.
and then heading back out to sea before coming ashore again in Georgia.
Yeah.
So,
Boy, it's a tough one.
all right, so that's all I have.
So we-
numbers updated, you said?
Yeah, I did update some numbers.
So we got an analysis, we got a nice forecast from Sarah, and now Shane's gonna show us the impacts of all this, or at least the potential impacts on some of the diagnostics he's been running on this.
So I should start by saying, certainly it goes without saying we're sort of in uncharted waters here with the wind speeds, right? And so you can imagine that the damages associated with something like this would be also in uncharted waters. So I have friends in Puerto Rico, and they sent me pictures this morning when they woke up. And so this is, even though 70-mile-per-hour winds in a lot of places, it's just a lot of trees down. It's fortunate Irma did miss this area because that northern shore of Puerto Rico is very low lying. There's a lot of flooding potential there. And so just a shift even 10 miles to the south would have caused quite a bit of flooding for Puerto Rico. So this is Irma Advisory 34. These are the peak wind gusts. This is what Justin was asking about. The software I'm using is HazardSMH, and it has a model in there that takes into account surface roughness and projects what the surface peak wind gusts will be and sustained winds. Coincidentally, when you compare these numbers, Wayne was showing me some numbers earlier this morning. The National Weather Service forecasts for peak winds were very similar to what we have here. And so this is sort of the pattern from Advisory 34 that you'd find. And so really, you're looking at two sort of almost disconnected areas. You have this Georgia, South Carolina area, We have peak wind gusts at 105, you know, some of the really stronger ones there along the coastline. And you've got this large area of 140 to 150 peak wind gusts. I think I looked at the area underneath this as about 3,500 square miles that are major hurricane or higher in terms of wind speeds. So about the size of Connecticut or a little bit bigger than that. And then hurricane force winds about 34,000 square miles, which is about the size of Maine, I believe. So that's this area that will have hurricane force winds. And so if you zoom in, this is sort of what you're looking at. And when you think about 155 mile per hour winds, you know, it goes without saying that wood frame structures are going to be extremely vulnerable.
What time is this for?
What's that?
This advisory?
This is advisory 34. And so what HAZUS is doing here,
This one this morning.
this is one from
No, I mean-
10 o'clock.
Okay,
National Hurricane Center.
Right, so it assumes the Hurricane Center's track at 11 a.m.
right, yeah, that's what I was asking.
Correct.
So what kind of winds?
So all the stuff we talked about with ECMWF.
I can't read
the West.
They're tiny fonts, so
Yeah, so
like Miami, what do you got around Miami?
right here on that 160s, 150s, I mean, that's if the forecast holds, right? I mean, you're looking at 155 mile per hour, 160 mile per hour winds. But notice how quickly, though, too, sort of that begins to decay as you go further to the west with that forecast path. And then if you come up here to South Carolina and Georgia, you're looking at these are the wind
But
speeds.
the populations are along the coastline and all that expensive.
Yeah.
along the coastline.
That's correct, right? So the reason this has long been talked about and discussed. In fact, we just completed a project in Georgia, and we're going to be doing some other work in Georgia, where we were looking at paths very similar to this, because this is the path that's going to cause probably the most damage, because you're taking these really high wind speeds and you're skirting the coastline. For Hurricane Andrew intersected Florida at a perpendicular orientation. Therefore, you have that sort of really high band of damages, but it's narrow, sort of right there where the eyewall's coming. Here, you're taking an eyewall, or you're taking that wind field, and you're dragging it across a long period, a long stretch. And if you think about the land values and the building construction along this area, it's some of the highest in terms of its value and the most dense. If you have to go almost all the way up to the DC area to find something similar to that on the Atlantic side.
You know what they do at the Cape in a situation like this? Any idea?
What they would do here?
What they did with Matthew.
So they just put everything in buildings up the way.
Concrete
They
buildings.
have these really reinforced structures that they move things into if they need to.
The vehicle assembly building, those doors, they were built for 200 miles an hour.
Whenever I go to Puerto Rico, they always joke with me. They're like, "We know how to build our buildings here. They're all made out of concrete," So that's the zoom in, and so here are the losses. Now these are wind only losses, and I want to be very careful here talking about this. I'll give you the example last year with Hurricane Matthew. So with Hurricane Matthew, I moved the center of circulation only 10 miles. And when you do that, it changed the losses from $30 billion to $3 billion, just moving that by 10 miles. Generally speaking, with a landfalling hurricane, you want to take a look at those losses sort of 24 hours out or 30 hours out, where you begin to get a narrower uncertainty with where the storm's going to go. But as of right now, when you take a look at this, and if I zoom in a little bit, you're looking at parts in the Miami area that have 500 million to $1 billion worth of losses just in small census tracts. Okay, we're thinking, several city blocks, because the building stock down here there's a lot of replacement value here. You've got some sky rises 40 foot, plus all the residential construction that's out in this area.
What's the east-west extent of that you're showing? Where you go from?
For here on Florida, or
Yeah.
so right in here,
Yeah, what's the width of that strip?
I'd have to measure it on
Well,
my
that's
screen.
constrained by the Everglades, right?
Yeah, the Everglades is right here.
Right,
So this
yeah.
is Miami.
So as an example, if it moved, is that 10 miles to the west? And it
So
would
you
put
can-
it over the Everglades?
Yeah.
Yeah, so if you can imagine if you move this 10 miles here and you're going from these 150 mile per hour. So if you come back up here, you can imagine just moving this.
Right.
You can see it here, just moving it, say 10 miles. This is what you're getting at, Brad. you're going to be going from 150 to 130, 120. So it's drastically going to change your losses here. I will say that the losses, I'm not going to say a specific number, but the losses are in the hundreds of billions of dollars. If you think about Andrew at $74 billion, I think is sort of an adjusted figure. And if you think of Katrina at 160, these were hurricanes, Andrew being maybe a little less intense over a smaller area. And if you think about Katrina being a less intense, going over a major metropolitan area, you can imagine with these wind speeds going over this sort of metropolitan area that hundreds of billions of dollars is probably not out of the question.
Andrew was a small storm, a small compact storm. So this storm making landfall could be similar in intensity, but much larger in size than Andrew was. So if you want to make comparisons between the two.
What's really going to be interesting is watching, if this forecast holds, I feel pretty confident in saying Harvey, if not the worst disaster on record, will be in the top 3 or so. And in the same year, within just a few weeks, we have the potential of having now the first worst or the second, like 2 of the worst disasters.
What's your latest estimate on Harvey? Or all said and done?
It's going to be approaching $100 billion probably.
And so this could double or triple it.
This could be Harvey and Katrina combined.
Yeah, I mean, it goes without saying that's a lot of money, right? I mean, so.
And that's only winds, due to wind.
This is only wind, right? This is only wind. Running the storm surge, of course, takes a lot of time, and it's very sensitive to the forecast track. So once we get into that 30-hour or 24-hour, then maybe start running some storm surge.
So in the past week, the stock price of Allstate has dropped 4.6%. And in the past month, 7.73%. My guess is you still want to sell if you got it.
Or buy, because it's low.
I'd wait a little bit before I say it.
I'd say buy insurance.
Flood insurance.
So here are just a few statistics here. The total building exposure, and this is an estimated figure. We find, though, when we go into communities, these numbers are pretty close to what, when we get the specific data from the communities, it's about $1.7 trillion of building exposure that's under the 50-mile-per-hour winds and higher. Under hurricane force winds and higher, it's about $1 trillion, a little over $1 trillion. And you're looking at, 242 million residential structures, and under hurricane force winds, 94 million structures. This displaced household number, which will fluctuate some, this is the number of households, and say 3 people per household would be 3 million. This means that's the number of people or the number of households that won't be able to return to their home because their home has been damaged beyond repair. So it's more than 50% damaged, and so they won't be able to go back to that structure. So that's that's a lot of displaced persons. And then I do want to show this, just how sensitive these things are. Just from the advisory 33 to advisory 34, the tree debris was 11 million tons, and it went up to 14 with advisory 34. Okay, just those small changes in the track. That's how sensitive these things are. And this happens with any loss modeling for an event like this. And building debris went from 33 million tons to 45.
Do you have a feel if you added the other elements like surge and flooding, what that displaced household number would become?
So when you're looking at this area in southern Florida here, you're already damaging these buildings beyond repair. So in addition to the storm surge, these people were already not going to be able to return. Right. So when you look at the losses here, the losses from the winds alone have totaled the structure. So you can use those without considering the storm surge. Where these things matter is when you look up here in Georgia and South Carolina. Okay, so here the wind has been working on the building to cause the damage. But then in addition to that, you have riverine flooding. You'll have rainfall damage. So once the building envelope becomes damaged, you can get rainfall intrusion. And then along the coastline, and you saw with Matthew what happened with respect to storm surge in South Carolina. You could have a tremendous, especially if, those last models, the GFS is showing 900 millibars off the coast of Florida here. And I think Derek pointed me to a paper 2 years ago about how the storm surge can often reflect 18 hours before, the intensity 18 hours before. So if you're thinking about, what it would take, you might be looking at category 4 or 5 storm surge into that area, even though the hurricane may be weakening.
Okay.
Right. The other, and we didn't mention this, but there would be tornado damage as well. As we saw with Matthew, which was a pretty prolific tornado producer, we would expect to see tornado damage here as well. One thing I wanted to make a point about, the problem we saw in Katrina after the fact was, especially along the Mississippi coast, was that many of the homes were destroyed by wind, but then further destroyed by surge. And trying to tease out to the insurance companies and how to deal with insurance, what damaged what, was a real problem.
This model can do that.
Yeah.
It takes a long time for that to run, and so that's why I'll probably start some of these tomorrow and Saturday. But they have a model where they look at different components. So foundations, floods can damage that. Roofing materials, that's the wind. So they've teased out a process for trying to separate those and do what's called combined loss analysis. So those are things that.
So the difference between why did you break up the residential buildings versus all the
Well, because
are they more likely because they're made out of wood to be destroyed than a big office building or something?
after looking at a lot of these communities, the residential building counts are the best counts with the data that I have. Okay, the U.S. Census data is where a lot of that comes from. As a nation, we don't really keep track of the number of commercial buildings and industrial buildings and all of these other segments. And so a lot of that is estimated counts. Okay, and so these are the numbers that we feel more confident about as residential. About 80 to 85% of our building stock in the entire U.S. is residential anyway. So that's a big percentage of your total losses. A lot of times I sort of just focus in on the residential loss. It's going to be the majority of your losses anyway.
How do you handle the situation potentially here where you have 50-story high-rises? As we know, the wind actually increases with height of these things.
This model is not doing
Yeah,
that.
do you know how they handle that? Because you could actually have a Cat 4 at the surface and a Cat 5 at floor number 30, right? The damage could vary, right? Just in that one building, just from that vertical. Yeah.
Now, the thing about that, though, is, if you're talking about Category 5 winds, this model's already maximizing the potential damage for that entire building. It does not look at this.
Doesn't discriminate by
it's
height.
not, well, no, it discriminates by height, but not the way you're talking about how the winds are increasing as they go up. Yeah. It's not doing that.
Okay.
It's just above and beyond the damage. I mean, it just adds to it essentially.
Well, what is the last
Correct,
round
that's correct.
So the one thing about any of this modeling too to keep in mind, and this is no different than flood modeling and looking at damages, in some ways you start with a number that's really high, let's say 500 billion, but people in Florida and other places have been given several days notice here. And so some folks are going to be going out to shutter, they're going to buy plywood, or they have their own shuttering structures. And so you can see a change in that loss come down with a longer lead time warning, especially for hurricanes. So you can bring some of those losses down that way. The single most effective way to reduce losses during a hurricane from wind is shuttering.
Right.
It varies what study you look at, 25 to 75%. It's a big range.
But isn't the building standards reduced over time since Andrew? Like they've got rid of a lot of the requirements for building?
There was discussion of, just recently, but I don't think any of that's been implemented.
Okay.
I don't think any
Governor
new
Scott or
buildings.
whatever.
Well, some of the best building code requirements for wind are in Florida.
Okay.
In fact, some of those building code requirements have spread across the country. I mean, I think like this idea of a hurricane strap is almost technically code everywhere anymore.
Well, that was learned from Andrew, right? A lot of those roofs weren't really pinned down.
Right, but even those straps fail at a certain level. So the initial damage assessment for Harvey showed that in the Rockport, Aransas area, that straps did nothing. It still ripped the roofs off the buildings.
When you start
you can see the straps like on the top of the building sitting there, and the roof is gone. I mean,
when you're in Category 4, the straps start to fail.
Yeah, I mean, you can only protect against so much. Your comment about shuttering well in advance is interesting because it gets at the problem of forecast skill, right? I mean, in order to, in this case, Home Depot, Lowe's, all the companies that are providing the shuttering materials have to pre-position that stuff so many days in advance, but we have to have confidence in forecast skill to know where to put all that. And so showing that really reduces the damages really gets at the heart of we got to really nail down the forecast track skills so that we can position the supplies well in advance.
It's a big difference. Now, again, Category 5 winds are probably not going to make a difference.
No.
But you know, when you're in these other areas, of course, I mean, it does make a big difference. So, I mean, if you're right along the coast here, I mean,
But even just inland, the winds decay a bit and can help quite a bit. So.
Once a window opening fails, not only do you have the pressure from the wind entering the building that causes damage, you have the missiles, you have rainfall, and so that's the opening protection is the key.
So for those who aren't familiar, you know, the wind damage from up to Category 3 major hurricane status is fairly linear. After Category 3, sustained winds of 100 knots is exponential because once you start tearing apart roofs and buildings and fences and all that debris starts flying around, then it just becomes a real mess and just does additional damage. So, you know, you could have all kinds of shuttering and stuff, but if you've got a 2x4 moving at 150 miles an hour, you're just not going to stop that.
Even setting out, like, I guess if you're staying in place, you're supposed to close every door inside the house also.
Right.
And go to the center of the house.
Like you would do with a tornado.
Projectiles.
Essentially, you know, tornado protocol. So.
I saw there's like 26 high-rise cranes in the Miami metro area that are only rated to Category 4 winds.
So they
it's
take
highly
them
likely
down?
that those, no, they can't get them down.
Yeah,
So
they can't.
They will
Yeah,
come
it
down.
takes weeks or months or something like that.
Yeah.
I mean, it's not easy to do.
Wow.
26.
Any other questions?
All right.
No?
Great, thanks. You do advisory chain, you gotta start your running.
Are we gonna?